join me here on stage, since Volker also will be the main moderator for this session and will guide us through the very interesting talks that now are about to come. Volker, welcome to the stage, and stage is also yours and the ones of your colleagues that you brought with you.
Yeah, thank you very much, Christoph. And welcome to the session on the energy data space. We have a very interesting lineup of 7 speakers that will present the current state of the art in data spaces in the energy sector. My name is Volker Berkhout. I'm working with the Fraunhofer Institute for Energy Economy and Energy System Technology in Kassel in Germany. And our objective today is to give you a broad overview about the initiatives and projects that are running across Europe to make data spaces happen in the energy sector. And we'll have some after session discussion in the breakout room, Saturn. So there will be not a direct Q&A after each presentation, but we'll be happy if you join us in the Saturn room to continue discussion and have questions in there. So there's one thing that I have to announce. We are having some technical difficulties in connecting Martin Gourier. We hope that we will be able to solve that within the run of the session. But yeah, hope we'll be able to have a presentation as part of the session. But anyway, we will start with the presentation by Massimo Bertoncini from engineering. Yeah, Massimo, the stage is yours. Please give us your insight.
Yeah, hello. First of all, thanks, Volker, for accommodating my time constraint, having one review of one of my projects still in the pipeline to wrap up this afternoon. So I will be moving immediately to share my screen and to share the presentation, which I prepared for you today. Very quickly, so give me 30 seconds. First of all, my name is Massimo Bertoncini, and R&D opportunity developer for digital energy at Engineering Ingegneria Informatica, which is a very large ICT company headquartered in Italy. The title of my presentation for today is the
Massimo,
one you can see. Yeah,
we cannot yet see your screen and your slides. We're at the folder.
You can see my slide right now? Hello? You can see?
No, I see your folder.
Very strange, because I launched my presentation. I don't know why it's not working. So maybe you have my backup, so you could be launching. But in my laptop, everything is working. So I don't know why. So I'm a bit,
Yes, I'll open your slides.
Yeah, you should be having my slide. So I don't know why.
No.
Okay, so let's go. So this is the title of my presentation. So let's go on with the next slide, please. So the starting point from myself is the current shifting and what we can call the energy revolution. As you can see in this slide, we are quickly moving away from the traditional one-directional landscape of the energy generation towards a many-to-many enriched relationships between different stakeholders. And in that sense, what is important is just to consider this new system-level vision, where it is important just to take into consideration the hybridization of energy versus non-energy value chains, considering as well other important arguments like decentralization of renewables, electrification of everything, and increasing demand for flexibility. Having said that, the next slide, please. So in that sense, data space are becoming for the energy sector more and more relevant due to a number of reasons. In particular, what is important from our perspective for data space in the energy is just that they could be contributing just to an increased system level cross-value chain energy, resource efficient and better yet greener quality of life. So this is an opportunity which should be captured and well understood by the energy stakeholder. And in that sense, energy data space for the time being are expected to enable a systematic cross-stakeholders interoperability and facilitated, this is the keywords, new energy-centered cross-value chain service. This service may be either increase the customer portfolio of energy operators while leveraging on new energy fingerprinting-based services, or opening up to new non-energy stakeholders the opportunity for deploying new service. Just let's consider mobility operators, where you can pay, for instance, the energy consumed at home, like kilowatt hours paid as kilometers. So you can see that this new perspective could be even an important asset, an important driver for enabling data space to become more and more relevant in the energy sector. Having said that, next slide, please. You can see here in this slide, I try to wrap up what is the state of the art on the smart energy data-driven platform. Often legacy systems are characterizing power network operators at transmission and distribution level. There is even a very weak links with the free commercial operators or with aggregators. There is a clear reluctance to share data with external organizations due to electricity network critical infrastructure security concern. And more than this, there is like a scenario like the winner takes it all, where everything seems to be centered on the electricity with respect of standards and layered architecture. So let's consider SAREF, SGAM, or CIM that are more oriented just to electricity. There are, I have to say, first movements towards a cross-stakeholders and cross-domain reference architecture, and while considering domain agnostic and data-oriented architecture within the DG Energy set up a bridge data management working group, together with other key players, we delivered an initial cross-sector electricity center reference architecture for data exchange, which actually takes or try to take into account the 5-word smart energy grid open reference architecture, IDSA data space design principle based on current and successful links with the H2020 OpenDI and links with the Gaia X conceptual architecture. You can see a bit more in of graphic in the next slide, please. In the next slide, you can see on your left on the top the conceptual cross-sector reference architecture, which I mentioned before as a measure results so far from Bridge, in which there is a total new dimension governing this cross-sectorial and taking dimension and taking into consideration concept and technology components and even organizational, concept like data provider or data consumers. And this is something that has been done or tried to be done in full cooperation, in full alignment with the data space design principle based on, on the white paper recently published, and even with the European data space and associated legislation. There is a lot of work to do right now. As you can see on the left on the bottom, that the data space dimension are at least 4, but this cross-sectoral reference architecture has started to do the first movements. At least we need to reinforce the interoperability, but we need to work as well on any other level, including trust, including data monetization and value, and even considering above all the governance and certification and aligning to the heterogeneous energy and electricity regulation, which are already in place, but which are really heterogeneous one from each other. Next slide, please. Based on this, you can see one of the seminal work which we are doing together with the IDSA and other common partners within the framework of the BD for Energy project. So we are reconciliating in this H2020 project, where engineering is the coordinating partner, myself acting as project coordinating, all just the regulation and all the technology innovation already in place, leveraging on the combination from the hints coming from the DG Connect and from DG Energy. trying just to demonstrate that this open, interoperable, data-driven reference architecture for smart grids going towards a common European data space perspective, while we are going just to validate a variety of cross-stakeholder use case against Gaia-X and IDSA conceptual architecture. So we are starting just to deploy to work on the deployment of a variety of technological connector compliant to IDSA and Gaia-X architecture. Having said that, let's go to give you further details. So you can see an initial classification of the energy data space multi-value chain use case in BD for energy. You can see how this fundamental cross-stakeholder perspective has been captured in BD for energy. We are having technical-oriented use case where you can have, for instance, direct current versus alternate current. Social-oriented use case where local energy communities are key priority, and even a business-oriented use case like considering cross-stakeholder energy and non-energy services at the interplay between different domains, however centered of the starting point as open point from the electricity. Next slide, please, just to conclude.
Massimo, I think we have to speed up a little.
Yes, we have 2 slides more. So you can see if you click on this conceptual architecture, zooming on the data governance layer, so you can click on in order to have all the text of the slide. So you can see how look like our data governance layer. We are going to deliver an IDSA compliant decentralized sovereignty preserving data access technological connector for trading off data ownership versus management, for enabling data access brokerage with a view to validate the 3 former category of use case which I presented before. So this is the work which we are actually doing. Last but not least, if we move on to the last couple of slides, please. There is a clear alignment with the energy Gaia-X architectural vision for the European energy vertical data space, so addressing general design principle, and even you can see even this familiar vision for the energy data space. And just to conclude on my last slide, just as takeaways, a lesson learned from this presentation, there are a lot of use cases as suitable candidates to be validated via IDSA Gaia-X compliant technological connectors. But we feel that we strongly need for scaling up at European level. There is an increasing yet clear understanding from energy stakeholders of the potential of energy data space for improving internal business process in terms of a business as usual, and eventually widening the scope of the business of the stakeholders through this multi-value chain service perspective. And last but not least, there is even an increasing need for a further technological upscale on interoperability, trust, data value compensation, and governance certification model. And last but not least, there is a stronger need for EU-level harmonization. I believe that this is everything from my side, and I will be happy just to answer if potentially, if I'm leaving the floor, potentially to wrap up some question, I will be happy to answer offline.
Okay, thank you very much, Massimo. So that was a great presentation and showing how much activity there's already on the architecture level on the EU, in EU projects and EU programs. So we continue with the next presentation, and that will be from Pieter Schuurmans from Interoperable. Pieter, join me on the stage.
Good afternoon, Herr Berkhout.
Great, yeah, welcome.
Thank you very much.
The floor is yours.
Yes, let me take a moment to share my screen to see. Yes, please let me know if you can see my screen.
Yes, works well.
All right, great. Thank you, Signore Bertoncini and Herr Berkhout. And good afternoon, and even now, good evening to all of you around the world. I am glad to have the opportunity of speaking on behalf of Interoperable during this energy stream, presenting the future of data sharing, but also in particular presenting the future of energy data sharing. First, who we are. Inopay is a consultancy for digital transactions. We provide services in, among others, payments, digital identity, and data sharing, operating in Amsterdam and Frankfurt. Sector-wide and cross-sectoral cooperation in digital market infrastructures is a cornerstone of our Inopay approach. With a proven track record, we build ecosystems for data sharing that enable all players to realize the full value of their data. Since 2005, we have been involved in the development of various cross-sectoral trust frameworks, or schemes, in the Benelux, Europe, and worldwide, for which you can see examples on the left-hand side. And one noteworthy data sharing example is iShare, who will also be presenting during this IDSA summit. As frontrunners in data sharing, together with key stakeholders in the Dutch energy ecosystem, we help develop a strategic foundation for an energy data sharing infrastructure, accelerating legislation on new energy data governance in the Netherlands in coming years. And also, as an IDSA implementation partner, we've been helping some of the energy use cases further together with the Adoption Accelerator team, for which you will hear more tomorrow in the presentation. We build these ecosystems for data sharing through co-creation, iteratively establishing agreements, including all relevant stakeholders, and including all building blocks on a business, legal, operational, functional, and technical level. And when we look at the energy market so far, energy supply has been comparatively simply organized in a strictly centralized top-down approach. Due to the energy transition, it is necessary to have an increasing power supply with decentralized producers and flexible storage of electricity. Therefore, the energy market is changing drastically from a past centralized structure, as you can see on the left-hand side in the middle of the slide, to a future largely decentralized network requiring a bottom-up approach instead. That is why in the near future, new forms of market organization will be required to handle a large number of energy suppliers, a large number of storage facilities, and consumers also taking prosumer roles. So a sharp increase in decentralized and volatile producers of energy due to the energy transition is leading to a need for new market structures. And as you can see on the left-hand side of this slide, insufficient data sharing is currently taking place on energy consumption and also on increasing energy production by prosumers. With more market participants joining the network, market communication across levels will increase and also become more complex. Whereas a multitude of use cases, which you can see on the right-hand side of the slide, require continuous data exchange between each of the various levels along the power grid. However, an individual bilateral exchange between each of the participants is too complex and also not feasible in practice. And a central market platform poses a potential security risk with a single point of failure and is also questionable from both a data protection and a data sovereignty perspective. So continuous data exchange is necessary to enable a multitude of important energy use cases. But how can we do that? So if we see in the near future, it must take place, data exchange must take place on a many-to-many relationship to be able to serve decentralized networks. As through decentralization, the energy sector is evolving from one-to-many to many-to-many data exchange. And that is why in the near future, to enable this required continuous data exchange along the levels in the power grid, energy market participants must start sharing data on a many-to-many basis. In turn, this enables the multitude of use cases, as we've seen on the previous slide, that will benefit, among others, network stability, participation of all market players, including these prosumers, and progress of the energy transition. However, this requires involved stakeholders in the energy sector to come together to collaborate and develop sector-wide agreements on data exchange, setting the foundation for an energy data space, enabling open and scalable data exchange while at the same time offering a high level of security and data sovereignty for all involved market participants. And if we check, in addition to developing sector-wide agreements for many-to-many data exchange, similar agreements can also be developed across domains, enabling even more new data sharing use cases. And one very good example of this is the Green Loans use case of the Data Sharing Coalition. The Data Sharing Coalition, in which IDSA is, by the way, also involved, is an open and growing international initiative in which a large variety of organizations collaborate on unlocking the value of cross-sectoral data sharing. And Inopay is heavily involved as the penholder of the Data Sharing Coalition. So in this green laundry use case, for which you can see a visualization on the right-hand side, homeowners can provide explicit consent to distribution system operators in the energy domain. These distribution system operators can then share energy data from the homeowner, from the smart meters, with banks and loan advisors in the financial and the mortgage domain. And by doing so, all stakeholders contribute to the energy transition by enabling propositions that will help support homeowners with making their house energy efficient. So this green laundry use case is just an example, but it can also be expanded to further scale the use case and enable additional propositions in and by other domains. By, for example, using the same data in other domains or sharing other types of data about a home. So this is just one example of how sharing data in and across domains enables a multitude of new use cases in the energy domain. New use cases that will allow all involved stakeholders to create additional economical and societal value and allow everyone to realize the full value of their data. So to summarize what I've been presenting now, with the future of data sharing and the future of energy data sharing is that it requires many-to-many data sharing ecosystems or data spaces to enable a multitude of valuable new use cases. And Innope, with its many years of international hands-on experience and expertise, is ready to help you build scalable, secure, and sovereign many-to-many data sharing ecosystems, enabling all players to realize the full value of their data. So if you would like to know more about what we do, feel free to reach out to me directly, either after the event or also during the event. Visit our website via the QR code on the left-hand side or via innope.com, or meet me at the breakout room Saturn right after this session so we can further discuss the future of energy data sharing. Thank you very much.
Well, thank you, Pieter. And I think that gave a very good introduction from the big picture going into directly use cases that are working cross domains. I think this mention of the energy transition and the paradigm shift that comes with it, in having prosumers and having much more communication needs on the lowest level of the energy system is very basic and very interesting for data space application. So yeah, thank you very much for your presentation. I think the next presentation is from Tecnaya and the Basque Energy Cluster. So Jose and Erik, could you join me on the stage?
Hello, hello.
That's great.
Can you hear me?
Yep.
Yeah. Okay, I'll share my screen.
Not yet.
Okay.
Okay, hi, Jose.
Hi.
I'm having some issues. 1 second. Okay. Okay, now it looks like it's working. Okay, so you should be able.
Yeah, that looks good.
Okay, so yeah, hello, my name is Erik Maqueda, and today, well, basically this is a joint project between Basque Energy Cluster. Here with me is Jose Ignacio, and yeah, this is also a project funded by the Basque, well, the business development unit in the Basque government, SPRI, and specifically our colleague Cristina Ollón. And also would like to thank to IDSA, a team, and also to Innope, Pieter, and Dove, and other colleagues for the continued support through the IDS acceleration program. So, Jose Ignacio, also if you would like to present.
Yes, okay, thank you, Erik. My name is Jose Hormaeche, and I'm the general manager of the Basque Energy Cluster. Just for you to know, this is the association of companies in the Basque Country that operate in the different energy value chains. Specifically, we include in our association a great number, I would say, of companies in the wind energy value chain, and that has been really the origin and pushing effort to launch this project in which we are collaborating with Tecnalia as a research center, and that is being also supported by the regional government. So next, Erik. Well, the project and the initiative we are working together starts, I would say, in the middle of that pyramid that tries to represent the wind energy value chain, and that red segment, the segment including component and system suppliers. That's one, I would say, one of the main strengths we have in the Basque Country, that we have a great number of companies, manufacturers of the different component systems and subsystems in the wind turbines, that are trying to improve their competitiveness by the use of data. They are working in technological developments to digitalize components, and in some cases improve the design of those components, and some other to implement or offer services of predictive maintenance, for instance, to their customers. But they noticed, and we noticed with them, that data nowadays in the wind sector, data are not easily available. In fact, there is some kind of, we call it that data monopoly or data access gap. It could be said in a different way. Only the original equipment manufacturers, the wind turbine manufacturers, that they are called OEMs in this sector, and the wind farm owners have really access to operational data in the wind farms. They are the only players in this value chain that can really leverage data and use them to improve their situation. The rest of the actors, including these component manufacturers, but also companies that have expertise in software development, big data, data analytics, and of course, all the stakeholders in the academia segment, research centers, universities, and so on, they could be data users, but in fact, they are not having access to that data. So next, Erik, having noticed and having addressed that challenge, it can be also noticed in the news and in the situation of the sector that in fact there has been some starting movements and some initiatives coming mainly from wind farm owners that are really wondering why the rest of the stakeholders, why they are not sharing data and sharing this kind of, or working together with all the companies in the supply chain to make use of data and improve the operation, maintenance, and the design of the wind turbines they are installing and they are operating. I would say that the main reason for this not sharing data could be in the, of course, privacy and confidentiality issues. I mean, the companies, the owners of data feel that their data and the core business they are managing should be protected. I mean, they are not willing to open up data that could maybe relevant for competitors or for companies in different situations. But also there is a sense that data have some value, and in some cases these big corporations, especially the wind turbine manufacturers, they feel they could miss some opportunities or maybe lose competitive position if they open up this data without without taking into account the possible return on the value of those data. So maybe, Erik, in the next slides you can present the solutions we are trying to offer to this issue.
Yes, indeed. Thank you, José Ignacio. Yes, and before going to the solution, and a bit to re-emphasize what are the, would like to emphasize a bit what are from the analysis and the research and all the collaborations and all the talks that we had with different companies from that energy value chain that José Ignacio, is that we concluded that the main barriers at the moment in the wind energy sector, in the offshore wind energy sector, to share this data or to get value from this data is actually, the first one is what we call data location. Well, this is really what we mean with this is that at the moment there is no central, there is not a central one-stop shop, let's say. There is not a marketplace for energy data where, like in Amazon, you can look for different items, you can look for different data and obtain what you need. At the moment, okay, there are few sites where there is some data, but they are quite, let's say, distributed, and they are not connected to each other, and it's difficult to find it. But even if we have access to that, let's say to those few small, a bit siloed location, the next problem comes with the quality of the data or the status of that data. And usually the problem is that data that is currently available is usually, let's say, completely open data, but the problem is that it's quite low quality data. So it's usually like few data with few parameters, usually not critical parameters, with no, with sometimes inconsistent labeling of data, and sometimes with no real value adding data, like failure data or label data and so on, that can actually be used to offer services, data services on top. So it can be used to share, to train digital twins and different machine learning models to then add some value to that data. Also, another problem is that these data from these different silos, they are not interoperable, so they don't share a common vocabulary. So we need to do like one-to-one connection, which in the end it's not scalable.
Eric, we have to look a little for the time. If you could a little.
Yep. Okay.
Go for it.
Yeah, and then finally, regarding the data value, which we believe is the biggest problem, is that at the moment everyone says that data is the petroleum, the new oil, and the reality is that no one, let's say, has enough trust to share this data. Okay, and this is the problem that we are working on together with different players of the energy value chain to try to convince the wind farm owners on the benefits of sharing this data, obviously, with the necessary mechanisms to ensure this trust that they need. So, very briefly on the main benefits of sharing data for all the actors of this, of the value chain. So, regarding the design phase, the capex, there is by sharing data, we believe that we can achieve a significant cost reduction of the manufacturing of the components through the optimization of the design, but also in the installation and commissioning phase, and also extend the life of these components. On the operational side, we believe that these technologies will allow us to get higher efficiency of components, also more reliable components, so avoiding downtimes and so on, and also improved OEM services with the use of predictive maintenance. And apart from this, there are other potential benefits, that is the development of new business models and services to help decision making, this data-driven services.
Could you end, please? I think it's very, yeah.
Yes, is this and then the conclusion. So, okay, and this is the platform that we are developing with the IDS connector and the broker, all based in IDSA. And Jose Ignacio, if you'd like to finalize with the last conclusions.
We need to involve big corporations in the wind energy sector at the international level to make it possible to share data with the rest of the value chain. That's the main conclusion.
Okay, thank you very much. And sorry for cutting you short, but the schedule is quite tight and there's the next sessions waiting to continue. So thank you very much for the presentation. And I think we have time for one more presentation, and that will be from Philippe Calvez from ENGIE. Philippe, can you join me on the stage, please? Well, Philippe. Okay. If you're not there, we could try Martin. Jean, is your network running right now? Great, I see you. And I can share your slides. But I can't hear you. Can you unmute yourself? Okay, I think there's still technical difficulties. Another try for Philippe. Philippe, are you on the line right now? Okay.
Can you hear me?
There he is. Great.
Yeah, sorry, I was in backstage asking how to share my screen, so I am back.
Okay. So yeah, great to have you here.
Thank you.
The floor is yours.
Okay, let me share my screen. Windows, share, full screen. Can you see my screen?
As well.
Okay, perfect. So hello everyone, my name is Philippe Calvez. I work at ENGIE at the R&D Center, and I will present briefly today the Platoon project. It's a H2020 project for digital platform and IT tools for energy, and I will focus on two main pillars that we have in Platoon, and it makes sense in this conference: sovereign and interoperable end-to-end digital ecosystem for energy value chain. So first, and I will keep the 8 minutes, I will not be above. First, the ID card of Platoon. So Platoon, I just mentioned, is a H2020 project, started in the 1st January 2020 for 3 years. We are 20 partners in 9 European countries, and you can see the different partners with the logo at the bottom of the slide. So a good mix between energy actors, research institutes, end users, big end users like cities, or big company like Post Italian, and some other partners that support us, of course, Fraunhofer, Consensus for Edge Computing, Politecnico for research, academic, TIB, and so on. So that's the ID card of Platoon. So first of all, I wanted to start with the pilots in order to show the different pilots that we have along the energy value chain, so different approach. So there is 3 main blocks, let's say the French, Belgium one, where we focus on predictive maintenance of wind farms with different data-driven services that we will develop based on the exchange of sovereign exchange of data. We have one in France where we work on smart energy building,
combining physical and data-driven approach. We have a strong block of Spanish entities, technology just presented, but other Spanish entities and cluster basque as well, working on different pilot
and use cases. So electricity, grid stability, energy efficiency as well for building. And we have a third big block of Italian partners working on smart energy, smart cities, physical model as well, and one in Politecnico di Milano on energy management of microgrids. And the last is electricity balance and
predictive maintenance system by our colleague from
Serbia, Pupin. And in all these pilots, we try to implement the 3 main pillars that I will present just after this slide. And we have the support from the technical side, from the German side, University of Bonn, Fraunhofer, TIB, some other entities that support for open call, standardization, UDG, IP, and consensus for edge computing. So the 3 main pillars, that's the most important slide, and the next one to illustrate of Platoon is we consider to do
end-to-end
digital ecosystem for energy value chain. We try to implement as much as possible in all the pilots these 3 main pillars. The first one is interoperability. It means be able to share not only data, but the representation, abstract representation of the data that can be shared between participants in order to understand which concept and to come to a consensus on the concepts that are handled. We develop or extend existing ontologies, and we extend with a missing concept, let's say, for the pilots that we have. So that's the first part. So once you have this, and before exchanging the data, you have this interoperability layer. You move to data governance and security. So that's the core of the today conference. We use massively IDS connectors, and we will deploy it with the support of Fraunhofer in the different pilots that you just saw in the previous slide. So you embedded not only the data, but as well the representation of the data. And at the end, it's very important to do these two main steps, but you need to be able to develop some services for energy, and these services will receive the data based on the IDS framework with the different rules and so on, but as well the interoperability layer in order to be able to replicate and scale these services in other contexts. So for an illustration, if you develop a services around smart energy efficiency building in France or in Spain, you can deploy it in Italy, the same representation of the data, and the data are secure when you exchange between the different multi-party or multi-stakeholders. So that's the that's why when sovereign and interoperable digital ecosystem. And another thing important is Platoon is not providing one platform, is providing a reference architecture. It means for each pilot, more or less, different architecture, ICT architecture platform are used with different components. But you need to be compliant with the reference architecture of Platoon. So it gives you a lot of flexibility. Of course, we are not replicating IDS. IDS is a core component it's used. You need to use the interoperability layer and the different ontologies. But
some networking issues. Okay. Philippe, I think your network is dropping out, unfortunately. So thank you very much so far for the presentation. I think the Platoon project is really a great opportunity that has a lot of actors across Europe working on 7 different pilots to build an energy data space and bring the ideas really into practice. So very interesting work you're doing. And I think with that, we'll have to wrap up the session. Unfortunately, we couldn't have my team join us. There is one presentation from Fraunhofer that will be postponed to a later part, but now will be available in the breakout room Saturn. So if you have any further questions and would like to continue the discussion, we're happy to meet you there.